Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about how we can graph the rational function y equals a over x. So a rational function has a specific form. It has the form of f of x equals p of x over q of x, where p of x and q of x are polynomials, and we have a stipulation that q of x can't be 0, right? We can't divide by 0. So the inverse variation function that we've talked about in a couple previous videos is f of x equals a over x, and this is considered a rational function. So as always, when we're talking about functions, we always want to keep in the forefront of our mind the parent function. Because with all these functions, linear functions, quadratics, cubics, all these different types of functions that we talk about in math, all of the functions that we see, they're either the parent function or they're a translation or a transformation of the parent function. So knowing the parent function is key. So the parent function for a rational function, it says the graph of the parent function f of x equals 1 over x. So that's our parent function. F of x equals 1 over x. And it is graphed, the shape of its graph is called a hyperbola. Right? So we got a parabola with quadratic functions, and now we have a hyperbola for rational functions. So it consists of two symmetrical parts, and these are called branches. So these are in white in our diagram here at the bottom right. Now, talking about domain and range, that's going to be all non-zero real numbers, because if we notice, we have a vertical asymptote at x equals 0, which is our y-axis, and we have a horizontal asymptote at y equals 0, which is our x-axis. So essentially for our domain, that's our x values, right? So we go left forever, right forever, except for when x is equal to 0. Same thing for our range, up forever, down forever, except for when y is equal to 0, because those are our asymptotes for our graph. So any other function of the form g of x equals a over x has the same asymptotes, the x-axis and the y-axis, has the same domain and range, all real non-zero numbers, as this parent function. So we're going to do one example in this video. We're going to graph g of x equals 6 over x and compare it with our parent function of f of x equals 1 over x. All right, so we're going to graph using our white table of values here, g of x equals 6 over x. So this will be our g of x function. We'll graph that one first, and then I'll graph in yellow the parent function. So for 6 over x, we know that our vertical asymptote is our y-axis and our horizontal asymptote is our x-axis. So I'm just going to use the points -3, -2, 1, and then 1, 2, 3. Notice I'm not using 0 there because x cannot be 0. So let's plug in -3. So we're just going to take 6 and divide it by all of these x values. So 6 divided by -3 would be -2. 6 divided by -2 would be -3. 6 divided by -1 would be -6. 6 divided by 1 is 6. 6 divided by 2 is 3, and 6 divided by 3 is 2. So now we can just graph these. I've just got a little bit of a sketch of a graph over here, so we'll estimate, and it'll give us the general shape of our graph. All right, so -3, -2 would be about right here, -2, -3, and -1, -6 would be right there. Okay. Now 1, 6 would be here, 2, 3, 1, 2, 3, and 3, 2. Okay, so now we have those 3 points. We know that we have a vertical and a horizontal asymptote at our axes. So now we can draw our shape of our graph that would look something like this. Okay. All right. So now let's switch up to yellow, and let's see how this compares to our parent function of f of x equals 1 over x. So now we're going to take those same x values, but now we're going to apply them to 1 divided by x. So 1 divided by -3 would be -1/3. 1 divided by -2 would be -1/2. 1 divided by -1 is -1. 1 divided by 1 is 1. 1 divided by 2 is 1/2. And 1 divided by 3 is 1/3. So now let's graph these points in yellow. We'll draw our branches, and we'll see how our graphs compare. So -3, -1/2, or excuse me, -3, -1/3. So that's going to be approximately right there. -2, -1/2, about right there. And -2, 1. Then we have 1, 1. We have 2, 1/2, and 3, 1/3. Okay. So now we draw our branches here. Notice how our branches are a lot closer to the x and y axis. Okay. So that's kind of the main difference there, right? Our g of x function has been stretched out away from the origin, if you will, but it still has the same domain, the same range as our parent function. right? All non-zero numbers. And so also when we look at the asymptotes, right? Same asymptotes, domain and range is the same, and really the only difference is that we've pulled it out a little bit away from the origin, okay? So that is how you can graph the rational function y equals a over x.